Let's take a look at two application problems that involve finding maxes or mins. My first problem says we have a garden store. We want to build a 600 square foot, so that would be the area, 600 square foot rectangular enclosure on the store's parking lot in order to display some equipment. 3 sides will be built of fence that costs $7 per foot, 1 side of cement blocks costing $14 per foot. Find the dimensions of the least costly enclosure. Least costly tells me I want to find the minimum cost. So I'm going to have to write a cost function. If I call the sides, the dimensions x and y, and we'll say that top side there is the cement blocks, then the cost of the x sides are going to be 7 times x. I have 2 of them, so 7x and 7x. For the sides labeled y, one of them costs 7y, and the other is going to cost 14y, the one with the cement. If we combine like terms, that gives us 14x plus 21y. Now, this equation has 2 variables, both an x and a y. We need to get this in terms of 1 variable. So I'm going to write a second equation. My second equation is area equals x times y, and we were given the fact that the area is 600 square feet. So x times y equals 600, and if I solve that for y, if I divide by x, now I have an expression that relates y to x. I'm going to take this y equals 600 divided by x and plug it into my cost equation. Again, replacing the y with 600 divided by x. This gives me a cost equation that has only 1 variable, only has x's in it. Let's see, I would multiply the 21 by the 600, and now my cost equation is 14x plus 12,600 over x. We can rewrite that last term with an x to the negative 1, and that makes it a little bit easier to find the derivative. Because now that we have our cost function, if we want to find the minimum, we have to find our critical points. That means we have to find the derivative and set it equal to 0. So the derivative would be 14 negative 12,600 x to the negative 2. I'm going to bring that x to the negative 2 to the bottom, and now I'm ready to try to find my critical numbers. I got a common denominator, so I could write this as a single fraction. So I multiplied the 14 by x squared over x squared. And now when I'm finding my critical numbers, I know that the only way a fraction can equal 0 is if the top equals 0. So I just have to solve 14x squared minus 12,600 equals 0. I'm not going to worry about when the bottom equals 0. A side of x equals 0 doesn't make sense in this problem. We can't have a rectangle with 0 length. It's also not in the domain of the function. All right, so add the 12,600 to both sides, divide by 14, and then we square root it. And I'm not going to put a plus or minus there when I square root it, just because it doesn't make sense to have a negative length. So I got x equal 30. Finally, I have to check, is 30 a min or is 30 a max? Hopefully it's a min, because that's what I'm looking for. I'm going to draw my number line. I'm going to pick a number that's smaller than 30. I did 20. And then I'll pick a number that's larger than 30. I chose 40. I'm going to plug those numbers into my derivative and see what I get. I got a negative when I plugged in the 20, so that tells me it's decreasing. Positive when I plugged in the 40, so it's increasing. And so that means 30 is a min, and that's exactly what I wanted. Now, this problem was asking for the dimensions. So x is 30 feet, And then earlier, I've erased it now, but we knew that y was 600 divided by x. So 600 divided by 30 is 20. And so this rectangle has to be 30 feet by 20 feet. I have a second example. It says a concert promoter has found that if she sells tickets for $50 each, she can sell 1,200 tickets. But for each $5 that she raises the price, 50 fewer people will attend. What price should she sell to maximize her revenue? So we want to maximize revenue. That means we have to write an equation for revenue. Revenue is going to be the number of tickets sold, number of items, times price per item, price per ticket. I'm going to let x equal the number of price increases, the number of times she raises the price, because then I can say that the price of the tickets it starts at $50, and then for each x, it goes up by 5. So price would be 50 plus 5x. Then the number of tickets sold, if there's no price increases, we start at the 1,200, but for each time we raise the price, we have to subtract 50 people, so minus 50x. Then to get my revenue equation, I'm going to take price times number of people attending. So the 1,200 minus 50x times 50 plus 5x. I multiplied that out. I used FOIL to multiply that out, and then I combined like terms. Now that I have my revenue equation, if I want to find the maximum, I have to take the derivative, set it to 0. Find those critical points. The derivative of my revenue would be 3,500 minus 500x. If I set that equal to 0, I added the 500x, divide by 500, I get x equals 7. Finally, we have to check, is this a max or a min? And this time to check, I'm going to use the second derivative. If r prime is 3,500 minus 500x, our double prime would be negative 500. This tells me the function is concave down, and critical points have to be maximums. So that's good. We were looking for a max. Let's see, finally, they say what price should she sell the tickets at? So I found my equation for P. It's 50 plus 5x. I'm going to plug in 7 for x. And so 50 plus 5 times 7 is 85. And that's my answer to this problem.